Here's an example of a problem where you have to use both Newton's second and Newton's third law together. Newton's second law relates the force on an object and the mass of an object to the acceleration it experiences. And Newton's third law says whenever one thing pushes on a second thing, the second thing pushes back with the same force. It might be summed up with equal and opposite forces. So we're going to use both those concepts in this problem. Let me read this problem to you. It says, suppose a 30-kilogram girl and a 60-kilogram boy play tug of war. If the boy experiences an acceleration of 1 meter per second, determine the magnitude of the girl's acceleration. Ignore friction. A little bit complicated. I like to start by drawing this one out. We've got a boy and a girl. Here's the girl. You can tell it's a girl, so we're going to give her some girly hair. And what do we know about the girl? Let's say we know her mass is 30 kilograms. And we're wondering what the acceleration is. That's my question mark. That's my unknown. Here's the boy over here. He's got a little bit bigger mass. His mass is 60 kilograms. And we actually know his acceleration. He's experiencing an acceleration of 1 meter per second. His speed is changing. His velocity is changing by 1 meter per second every second. And we also know they're playing tug of war, so I'm going to draw a rope between them. And it says ignore friction. So I don't know, they're on ice skates, there's so little friction, we're just going to ignore it. Either on roller skates, whatever. Do not have to worry about friction. So we need to use both Newton's second law, and his third law. So Newton's third law says that whenever one object puts a force on a second object, the second object puts the same force the other direction on the first object. So kind of indirectly we can look at this and say, okay, well the girl is being pulled this way. This is the direction of the force on the girl that the girl experiences, and the boy is being pulled this way. And not only are they opposite directions, they're equal values. So the force on the girl in this case is equal to the force on the boy. The force on the boy we can actually figure out. The force on the boy is mass times acceleration, and use the boy's mass, the boy's acceleration. So his force is, let's see, 60 times 1, okay, that's 60 newtons. And it's to the left. The girl's force is the same amount, but to the right. So the girl's force value is the same, 60 newtons. And now all I have to do is say, okay, what's the acceleration of the girl? This is when Newton's second law comes in handy. Acceleration is force over mass. So the force on her is 60 newtons, same as on the boy. Her mass is 30, so her acceleration is 2 meters per second. Which you probably could have logically figured out by just saying, oh, it's the same force and half as much mass, probably twice the acceleration. But this gets you the whole process of saying the forces are equal. So if I can find one force, I know the other force is the same amount, just in the other direction. And then I can use my numbers for the other object to solve for the missing value.